Hey guys, we are on page 5 of our final review for intermediate algebra, so we're looking at number 29. Okay, we do have some word problems, but they are not as bad as they look, right? Okay, I even give you the equation that we are going to be using. The equation is y equals a times 1 plus or minus, depending on if it's growth or decay, some kind of a percent, and then that's going to be to some exponent. Okay, a up here refers to your original amount. The percent, we do have to change a percent to a decimal, and then x is the amount of time. Okay, that amount of time is in decades in problem number 29. So we have to figure out how many decades will have passed. All right, so let's read through. In 2014, the population of Overland Park was 174,921. And that population is growing at a rate of 3.6% per decade. What will Overland Park's population be in 2044? And we're going to round to the nearest person, so we should be getting whole numbers for our answer here. If we don't get a whole number, we're going to round. All right. We are told that the original amount of people in 2014 was 174,921. So that's what letter A is. Okay, so we're going to plug in 174,921 right here. The next thing we need to figure out is whether there's going to be a plus or a minus after that 1. Plus for growth, minus for decay. We are told in the problem that we have a growth, so we're going to put a plus there. Okay, the percent is going to go next. We have a 3.6%, but percents mean out of 100. So we're going to take that 3.6%, and we have a choice. We can either divide by 100, and that gets us 0.036, which is going to go right up here, 0.036, or you can take that 3.6 and move the decimal 2 spaces to the left. It's 2 spaces because 100 has 2 zeros. All right, last thing we need up here is our x value for our exponent. That has to do with time. Okay, we are told that we're starting this in 2014 and ending in 2044. So 2014 subtracted from 2044 is 30 years. But we're not going to use the number 30 because we are told that this is in decades. So a decade is 10 years, so 30 years equals 3 decades. Okay, that 3 is going to be the exponent. So I want you to notice that once we have plugged all those numbers in, there is no x or anything like that left, no variables. So we're going to plug this whole thing, starting with 174,000, starting with there, we're going to plug that into the home screen on the calculator. Okay, to get that exponent of a 3, remember that you're going to hit that caret key, which is all the way on the right side of the calculator. It looks like this. That's our caret key. It's just above the division, I believe. Okay, once you plug that all in and hit enter, we end up with 194,500.722, and then some more decimals. And we have to round this to the nearest whole person. Well, 0.7 is almost a whole person, so we're going to take that 0 right there and make it into a 1. So it's 194,501 people. Okay, number 30, another word problem, and I do give you the equation again. You need to figure out A, P, R, N, and T from the problem, and then you can just plug them straight into that formula. Okay, A is the final amount. Well, we are looking for the final amount. Find the final amount is what it asks for. So we do not know what A is. P is the principal. Okay, so that means your original amount. We have $720 to invest, so that is P. R is an interest rate. Again, just like on 29, we are moving the decimal on that 3.8, changing it into a decimal. So we can either move the decimal 2 places or divide 3.8 by 100, and we end up getting 0.038. Okay. We are told that we are compounding semi-annually, that's important, and 3 years. All right, so let's make sure that we're not switching these two things around. 3 years. 3 years is time t. So t is 3. Semi-annually means that we are doing this 2 times in a year. Okay, so n is how many times we're compounding per year, so n is the 2. From here, we're just going to rewrite a equals p. P is 720, parentheses 1 plus. It is definitely a plus because we are growing, all right? We're not spending more money. Our interest amount is growing. The rate goes on top. Rate is 0.038. N on the bottom is a 2. And up top, n times t, so that's 2 times 3. And plug that all into the calculator. Calculator gives you 806.0789. And we are going to round to the nearest cent, which is 2 decimal places. So that 7 is either staying a 7 or becoming an 8. Okay? The fact that this number after it is an 8 means that this 7 is so close to being an 8 that we are just going to pretend it's an 8. Okay? And we will have $806.08 in that account. All right, logs are another one of those really quick things, but you need to make sure that you practice them so you know where all of your numbers go. Okay, writing an exponential function into logs. We are going to label all of the numbers that we have in this problem. So we have 6 to the 3rd power equals 216. Let's start by labeling the base and the exponent. 3 is an exponent, 6 is a base. Okay, now I'm going to scoot over to problem 32 and do the exact same thing. Okay, we read this as log base 10 of 100 equals 2. So we said log base 10. 10 is the base. Okay. And then when we learned about these, we talked about how logs are exponents. So logs equal the exponent. So 2 is going to be the exponent. There it is. So at this point, all we're really doing is switching between the two forms. So that means number 31 is going to have the word log. And then we're going to put its base next. So the base is going to be down below next to the little G curve. That is the 6. Logs equal exponents, so the 3 should be on the right-hand side, which means that the 216 is going to be after the word log. Okay, 32 is going backwards. We have a base of 10 and an exponent 2, so that's 10 squared. And then our equal sign, and then that 100 just fills in that very last spot. 10 squared equals 100, which is a true statement. 33, we're finding extraneous solutions. We just had this chapter. Okay, extraneous solutions are the answers that x is not actually allowed to equal. So we're going to just look at the denominator. X plus 4 is not allowed to equal 0 because denominators cannot equal 0. And then that means that x minus 1 also cannot equal 0. When we solve both of those equations to get x by itself, we get x cannot equal negative 4, and on the other one, add 1 to both sides, x cannot equal positive 1. So those are the two extraneous solutions. To do it a little bit faster, we can just look at whatever that denominator is, and if it's a simple one like x plus a number or x minus a number, all you have to really do is do opposites, just like when we were doing zeros on a different page of this final review. Okay, on 34, we are simplifying the rational expression, so we need to make sure that everything is factored out completely, and then we can start canceling stuff. Okay. I see a factor on the top and the bottom that match. I see a 2x minus 5 and a 2x minus 5. They perfectly match, so we get to cancel them out. Okay, the x plus 3 and the x minus 3 do not perfectly match, so we cannot cancel them. Okay, on the left side, we have a 3x and a 6x. Well, x and x perfectly match each other, so we can cancel those out. And then 3 over 6, I'm going to write it out over here, is the same thing as 3 divided by 6. And you might notice that 3 over 6 is the same thing as 1/2, or you might want to hit math, enter, enter, like do 3 divided by 6, and then hit math, enter, enter on your calculator, and it will give you the fraction 1/2. Okay, so our job here is to just rewrite. Okay, the 3 and the 6 reduce down to a 1 and a 2. So the 1 on the top and the 2 on the bottom of that fraction. There's an x plus 3 still on the top, and there's an x minus 3 still on the bottom. Okay. This 1 over here on the left is not actually important because there's more stuff up there on the top. So our answer is going to be x plus 3 over 2 times x minus 3. Don't multiply that out, just leave it all factored. Okay, 35, we are factoring this time. So we are trying to make our problem look like number 34, all factored out on top and bottom, and then we can cancel, hopefully. Hint, you're going to be able to cancel because I want you to be able to show that. Okay, top, we have x squared minus 2x minus 8. There's 3 terms. The first one is an x squared, and there's an invisible 1 in front of that x squared. So that means we can do the shortcut method, meaning we'll have an x and an x. Since the last term, the negative 8, since that is negative, we are going to have different signs. So 1 plus and 1 minus. And since the middle one, negative 2, that b is negative, that means that the negative one is going to be the bigger of your two numbers. So we're looking for two numbers that multiply to get negative 8 and add to get negative 2. Okay. They happen to be negative 4 and positive 2. Okay. Double check them, make sure they work. On the bottom, same deal. We have shortcut method because the very first term is just an x squared and we have 3 terms. Since our last term is negative, we are going to have 1 plus and 1 minus. And since our middle term is negative as well, that means that our bigger number is going to be negative. Okay, 4 only has 2 sets of factors, 4 and 1 and 2 and 2. The 4 is going to be negative and the 1 is going to be positive because 1 times negative 4 is negative 4 and 1 plus negative 4 is that negative 3. Okay, now I did give you guys a hint at the beginning of this problem. Some of your factors are going to be able to cancel. So if you get at this point nothing that matches from top and bottom, something went wrong somewhere. Either you messed up your signs or you picked the 2 wrong numbers, like the 2 and the negative 4 or something when you made your chart. So those guys cancel. Okay. From here, all you are doing is rewriting whatever is on top still stays on top, whatever is on bottom still stays on the bottom, and that's our final answer. Okay. When you try and add or subtract rational expressions, rational meaning you have fractions and you have polynomials on the top and the bottom, when you're trying to add or subtract, you need to make sure that your denominators match. So do the bottoms match? Yes, in fact they do. 3x plus 6 is the denominator on both fractions. So that means that when we add these two fractions or subtract them together, the denominator is still going to be 3x plus 6, which is awesome. All right, let's look at the top. We have a 5x minus 7 and we have a 4x plus 3. However, there's a minus in between. Remember that when you are subtracting, you need to distribute that negative, like multiplying times the negative 1. So that top should really look like negative 4x minus 3. And then you can change that guy in the middle into a plus. Okay. From here, we're combining like terms straight across the top. We have a 5x minus a 4x is a 1x or just an x. And then we have a negative 7 minus a 3, which is negative 10. Okay. There's nothing to cancel on the top and the bottom. Even if we factored the bottom into 3 times x plus 2, there would still be nothing to cancel, so don't worry about it. On 37, we are adding the rational expressions. Like we said on 36, the denominators have to match perfectly before you can do that. But the problem is that they don't match. So let's zoom in a little bit. Our first denominator is an x plus 2. Stick some parentheses around that and stick some parentheses around the x minus 3. Okay, since the first fraction has an x plus 2 down there, we have to give the second fraction an x plus 2 as well. But if you multiply a denominator, you also have to multiply a numerator. Okay, our second denominator has an x minus 3, but the first one is missing that. So let's give the first one an x minus 3 on the bottom, and then you also have to multiply it times the top, or else you change what the problem is. Okay, on the top of the first fraction, we're going to take the 3 that is there and we're going to distribute it to the x and to the negative 3. So the tops, you're going to go ahead and multiply it out. So we end up with 3x minus 9 when we distribute. The denominator is x minus 3 times x plus 2. Second fraction, we have a 4 times an x plus 2 on the top, 4 times x and 4 times 2. So that is 4x plus 8. The denominator, just copy it down, x minus 3, x plus 2. You could technically multiply out the denominators, but this is going to be multiple choice on your final exam, and it will have them still factored out on the denominator. So do not bother unless you really, really feel like it. Okay, from here we are supposed to be adding. Our denominators perfectly match, so we're going to keep the denominator, x minus 3 times x plus 2 down there. And on the top, we combine like terms. So we have a 7x minus 1. Okay, number 38, solving rational equations. This is where we get to cross multiply. So cross multiplication can only happen if you have an equals in between. Okay, so it has to be a proportion, which means fraction equals fraction. I'm going to go ahead and stick parentheses around both denominators. Okay. As we cross multiply, we are going to multiply the 6 times the x minus 5 and put that answer here. And we'll multiply the 2 times the x minus 1 and put that answer over here. Okay, so 6 times x minus 5, and then bring down that equals, and then 2 times x minus 1. Okay, looks like we have to do some distributing. On the left, we have 6x minus 30. On the right, 2x minus 2. And then this becomes a multi-step equation because we have x's on both sides of the equals. So you're not allowed to just combine like terms because the x's are on the two different sides. So we have to choose. We can subtract 2x from both sides or 6x from both sides. I usually pick the smaller option, so I subtracted 2x from both sides. And now we have a two-step equation. 4x minus 30 equals negative 2. I'm going to add 30 to both sides. So 4x equals 28. And then divide both sides by 4. So x equals 7.